question number 2. It says, determine the bond energy of an HCl bond given the following information. And then they give you a table with some thermodynamic data. So the equation is basically CH4 plus Cl2 forms CH3Cl plus HCl. Okay, just do a real quick check. That's already balanced, but you always want to make sure. So when you do these bond energy problems, the basic idea is that there's a change in enthalpy over the course of the reaction, and we're going to call that change delta H of reaction. Change in enthalpy of reaction. Okay, and what that's equal to is you can model this quantity through the breaking of the bonds of the reactants and the forming of the bonds of the products. So the concept behind this is basically these molecules you have to like cut them up, break them apart to have them react, and then to form these bonds you have to use so when you do that, you release energy, you gain energy from the bonds that you broke. In contrast, when you're forming the bonds of the products, you have to put in energy to make those bonds instead. So what we say here is that the change in heat of the reaction is H of the reactants minus H of the products. And the reason that this is positive is because from the reactant bonds, you're gaining the energy when you break them, whereas you have to use up energy to form the bonds of the products. Okay? So basically what we have to do is add up, to define the change in H of the reaction, we have to add up all the bonds of the reactants and then subtract all the bonds of the products. In this case, it's a little different because they actually gave you the change in heat of the reaction, and you have to figure out the bond energy of one of the bonds. In this case, it's HCl. Find the bond energy of an HCl bond. So basically we have delta heat of reaction. What I like to do for these problems is draw out all the molecules that are reacting before you do the problem. So this first one is a CH4. That looks like this. And then you have plus Cl2. Right? And that reacts to form CH3Cl plus HCl. Okay? Just draw Lewis structures of everything. Okay, so basically what's going to happen here is we have our delta H of reaction is equal to negative 113. And that's equal to all the H's of the reactant bonds minus all the H's of the product bonds. So here you see that we have 4 CH bonds, so that's going to be my first term in the equation. I'm going to have 4 times the value that they give for CH bonds, and that's 414. So 4 times 414, plus, we're continuing on with the reactant still, so we have 1 chlorine-chlorine bond. So the energy for that is 1 times 243. Okay, so now we're done with the reactants. We have to subtract the products. So as you can see, we have 3 carbon-hydrogen bonds. 1, 2, 3. So we're going to subtract 3 times 414. Then we still have some more stuff to subtract because we're not finished with the products. So we're going to subtract 1 carbon-chlorine bond. So minus 1 times 339. And then lastly we have to subtract one HCl bond, so -1. They don't give us that on the chart, and that's because that's what the question's asking. They want you to find the bond energy for this. So you could write HCl in brackets here. I'm just going to use X. So basically you have one equation, one unknown. You take this out, because we already defined the delta H of reaction. So you're going to move everything over to this side and add and subtract it all up. And what you should find is that X equals 431. Yeah, X equals 431. So that corresponds to answer choice 5 on your test. And what you should note is that bond energies have to be positive. So answers 1 and 3 are useless. But yeah.